And I know I do not allow performance or grade. I try very hard not to allow that to reflect how I feel about you or how I treat you. Okay? I had a teacher in high school that used to yell. I mean, she would like embarrass and yell at students when they didn't turn in an assignment or if they failed a test. I mean, she would like throw it down and yell. I mean, it was like, and I hated that. I was like, isn't a bad grade like punishment enough? I mean, why do you have to like embarrass a student? Anyway, so I've let my past try to help, develop my teaching philosophy and all that kind of stuff. But at the same time, I also know what kind of student I was, and I was lazy, and I was a procrastinator, and so I want to try to steer you in the direction of not being lazy, not being procrastinator. Okay. Every single one of you were better students than me. Every single one of you. I kid you not. It's not that I made horrible grades, but I wasn't challenged in high school very much. And that's the reason my freshman year in college, I got my butt handed to me. You do not want to get your butt handed to you. Okay, so y'all have lunch at 12:55, so I'm trying to get you out of here at 12:52.
I said 12:50.
Well, that's kind of early. Get up there too early, they don't want to let you in. Okay, so here's what I'm doing.
That's not a thing.
Here's what I'm doing. Look. So, now that does happen sometimes. I've had people like, hey, you're not supposed to be in here yet. So, let's go. Alright, so you have the mouth. Then what do you have? Pharynx. That's basically your throat. Okay. You have the esophagus, which leads to stomach. Alright. Okay. You have like the gastric opening and the pyloric opening, all that kind of stuff. Then you go to the duodenum, right? The duodenum of the small intestine. Okay. Then the jejunum of the small intestine. Then the ileum of the small intestine. Okay. Which kind of goes to the large intestine and what?
Cecum.
Cecum, then colon.
Right? And then the colon, which limb?
Ascending.
Ascending.
Transverse.
Colon, which kind of goes to the transverse colon, which goes to the descending colon, which goes to the sigmoid colon, which goes to the rectum,
Yeah.
and then what? Anus. All right. Yes.
Why does the or even bile at this point? Why does that have to go?
It's not bile.
Or no, for the when it's in the large intestine.
Large intestine, chyme enters the large intestine.
Yeah, but why does that have to go up, back up?
It just does. I don't know. I have no clue. It just does. All right, so if you're looking at, all right, so we eat food. When food is mechanically broken down, chewed, and mixed with saliva, it becomes bolus that enters the stomach, and it becomes chyme. Travels throughout the small intestine, chyme enters the large intestine, and becomes feces. That's very easy. Okay, so let's look at some enzymes.
Yeah, could you write it beside it?
Okay. All right, food enters mouth. Chyme enters esophagus. I guess in the throat. Well, I guess it enters the pharynx off the esophagus.
I thought it was
Bolus.
I'm sorry.
Yeah.
You're right. Bolus
Oh my goodness.
enters pharynx, esophagus. That is if you chew it and mix it well enough. Sometimes we actually swallow food. So we haven't chewed it well enough. All right. Chyme leaves the what? Leaves stomach.
Then it becomes
Okay. And it goes to small intestine. Okay. Inner small intestine. And then changed to feces and what?
Intestine.
And the large intestine. Colon. And the colon.
Your colon.
Yeah, colon makes up like 90-95% of your large intestine. So that's why it's used interchangeably. It just makes up a large percentage. Yes?
Once chyme leaves the stomach, does it become and enters the small intestine?
It stays chyme throughout the small intestine.
And then bile is just a secretion.
Bile is just a secretion from the liver. Okay? Alright, so let's look at secretions and where they come from. Okay? So you have, let's use a different color. Let's use blue. See if I have a good blue one. Have a good blue one? Maybe. Alright, so the mouth. Alright, so the mouth. That's way off. Rejected. Okay, maybe this way.
Let me see.
Okay. Alright, so you have amylase in the saliva, right? Closer to me. Alright, amylase is in the saliva, right? What does amylase break down?
The simple sugars or carbohydrates.
Alright, it actually breaks down carbs. You get more specific, breaks down polysaccharides. Alright, those are complex carbs. Okay? Alright? Stomach secretes hydrochloric acid. Right? Secretes, what does else secrete? Starts with P. Pepsinogen, and in the presence of hydrochloric acid, that becomes pepsin. And what does that break down?
Amino acids or proteins.
Proteins into polypeptides. So basically, you're breaking down. One way to look at that is you're breaking down a chapter of a book into a paragraph. Okay? All right. It also secretes what else?
Something with an S.
Secretes intrinsic factor.
Where I was wrong.
Intrinsic factor is what binds to vitamin B12 and allows its absorption. Okay, produce mucus. Is it the only thing that secretes mucus?
No.
Where else is mucus secreted?
The entire.
The entire GI tract. And the main purpose of mucus for the entire GI tract is for what?
Lubrication.
Make sure it goes
Lubrication. All right, allows us to go through. But what's the purpose of mucus in the stomach?
Oh, so it doesn't like burn through it.
That's right. Without mucus, hydrochloric acid would dissolve the inner lining of the stomach. All right, so it protects the inner lining of the stomach. Okay, and then finally you have gastrin, which is just a hormone to help regulate the production of the other things. Okay, what's absorbed? Name three things that's absorbed from the stomach into your bloodstream. No, it has to bind with intrinsic factor first. It absorbs straight from the stomach into your bloodstream.
Simple sugars.
Honey.
Syrups. Yeah.
Honey, syrups, honeys, concentrated. Not just any. Alcohol,
And
aspirin.
Wait.
Yes,
You have to know that.
that's easy.
Wait,
That's
what is
easy stuff.
I'm saying,
Alcohol,
like,
honey, and
Yeah.
aspirin.
that wasn't the question.
Okay, yes. Aspirin, alcohol, honey.
What was the one?
I said gastrin. I said three things that are absorbed from the stomach straight to our bloodstream. Okay, honey, aspirin, alcohol. All right. From the small intestine, probably mostly in the duodenum. Okay, you have disaccharidases, which breaks down
Disaccharides.
disaccharides. Okay, these are disaccharides. How many simple sugars make up a disaccharide?
2.
Two. Right? So like lactose, and you don't have to know what it breaks down to, but lactose will break down into galactose and glucose. Right? But disaccharidases, what else? Peptidases.
Peptide.
All right?
Lipase.
These break down peptide chains into amino acids. All right, so you're looking at like breaking down words. Hold on a second. No, here we go. Let's undo this. So proteins and polypeptides is like breaking down a paragraph into sentences. This is like breaking down a word into letters. The middle part is like breaking down a sentence into words. Okay? So you're getting less and less complicated. Alright? Proteins are very three-dimensional. Their shape is very, very important to their function. Polypeptides are more two-dimensional, like a sheet. Right? Peptide chains are more like they're linear. Alright? Just like a chain.
The peptide chains come from the
Yes.
polypeptide?
Peptide chains make up polypeptides. And then amino acids are just individual units that make up proteins. Okay? Alright, so as far as secretions go, that's it with the GI tract. But what else? What are two very important accessory organs that have secretions?
The liver and
Okay.
pancreas.
You have the liver. Let's put it on this side. You have the liver, alright, which secretes what?
Bile.
Bile, which either goes one of two places. Either into the gallbladder or straight to the duodenum. It can go in the gallbladder, alright, which then dumps into the small intestine. Alright, I do want you to know this. Okay? So, from the liver, you have the bile goes from the common hepatic duct. Okay? That's what takes bile from the liver. From the gallbladder, bile is secreted along the cystic duct, and they merge to form the common bile duct. I don't care that you know the ducts that go straight from the liver to the gallbladder, okay? But if it's coming straight from the liver, it goes the common hepatic duct, then the common bile duct, which goes to the duodenum. It comes straight from the gallbladder, it's the cystic duct, common bile duct, to the duodenum. All right? What does bile do? Does it digest anything chemically?
No.
No. No.
Regulate the acidity of
Okay, it does two things. It helps to neutralize the acidity of chyme. All right, so it helps to raise the pH. It also does what? Does it help in fat digestion? Yes. Does it chemically digest fat? No. It helps to separate fat. The word is emulsify. Emulsify means to break down into smaller pieces. Okay? Yeah. So bile neutralizes chyme. And you should know what that means. What's the pH of chyme? Very low because of hydrochloric acid. Alright, so neutralizing it means you're bringing it what?
higher, making it more basic.
Make it more basic so you're raising the pH. And the other thing you're doing is you're emulsify fats. Emulsify is a mechanical, very physical process, just separating it. Same thing detergents do to soils in your clothes. Alright? So, let me put bile in blue. Okay? Alright. Y'all see blue's pretty good, right? Sucrose, table sugar. That's a disaccharide made up of glucose and fructose. Yes. Okay. What's the other accessory organ?
Pancreas.
Or liver? Pancreas. Right? Pancreas. Alright? This is its exocrine function, not its endocrine function. So it secretes what? Bicarbonate ions. Alright? What does bicarbonate ions do?
Also
Bind
helps.
with
It also neutralizes the acidity of chyme. Look, watch this. Watch this. What do you think the bicarbonate ions is going to react with in the chyme? What makes it acidic?
Is that
What?
H plus hydrogen ion.
It's going to combine with the hydrogen ions, which makes the chyme acidic. And what is it going to form?
water and carbon dioxide?
Water and carbon dioxide. Can't get any more neutral than that, right? Okay. You wonder where all that gas comes from. Of course, the gas is sulfuric and nitrous too, but.
That means you got that gas.
But the gas that you smell is actually a lot of methane, some sulfur, some nitrous type of compounds. Okay? Alright. That's how it. I don't know if that helps. That helps you understand, hey, that's what's going to neutralize acidity of chyme. But it doesn't help break down fat. Okay? So it just neutralizes acidity of chyme. Whereas bile does two things. Alright? So what else do you have for the pancreas? Alright, I'll write it up here. You tell me what it does. Lipase.
It breaks down lipids.
Breaks down lipids and fats, right? Okay. All right, so it breaks down lipids. Nucleases.
Break down nucleotides.
Breaks down nucleic acids like DNA and RNA. Those are both nucleic acids. Okay. Amylase. Carbohydrates. So it's breaking down complex carbs like polysaccharides. And trypsin slash chymotrypsin, which does what? All right. So we have an enzyme that breaks down proteins into polypeptides. We also have a protein that breaks down peptide chains into amino acids. What do you think this does?
Breaks down polypeptides and peptide chains?
Yes, breaks down polypeptides into peptide chains. That's like breaking down a sentence into words. Okay? So amino acids are like letters, peptide chains are like words. Polypeptides are like sentences. Proteins are like paragraphs. That's just an analogy, right? Okay? Where does all this dump?
Into the common bile duct?
No.
Dual.
Well, not really. It's actually called, I don't even know what it's called. It's actually secreted along the pancreatic duct, which makes sense.
Mm-hmm.
And then will barely merge with the common bile duct right before it gets to duodenum. I don't even know if there's a name. It might be. All right? But all this is also going to dump into the duodenum. Okay? All right. Now, last thing, and let's come over here. Okay? All right. Okay. So, all right. So you have secretin. Cause, liver, gallbladder, pancreas. All right. Secretin. Secreted because of the low pH of chyme. Alright, the acidic nature of chyme. Right? Okay, so let's think about this. We're going to raise this chyme, right? Alright, so what it's going to do is it targets the liver to increase bile production, secretion. Okay? All right? What's going to raise the pH of chyme coming from the pancreas? Over there. Bicarbonate ions. All right, so it's going to target the pancreas to increase bicarbonate ion secretion. Okay, you see how that is helping to have a negative feedback mechanism on this, right? You have cholecystokinin. All right, this, the cause of its secretion is because of high amino acid and high fatty acid. What relative pH does amino acid and fatty acid have? Above or below 7? Should be below because they're acids. Are they strong acids? No, but they're still an acid. Amino acid, fatty acid. So what has a person eaten to cause their cholecystokinin levels to go up?
Fruit.
Meat. Fruit. What? Meat and lots of fat.
What is that called? How do you pronounce it?
Oh gosh, I just butchered it. I'm sorry.
I think it's E.
Cholecystokinin. Cholecysto means gallbladder. It's one of your word parts. Kinin means movement or acting upon. Okay? Alright. So this is secreted because of high amino acid and fatty acid. If this is high, is this going to be low?
Yes.
Well, here's the thing. If you add an acid, even a weak acid, to another acid, no matter how strong it is, does it get more acidic or less acidic? More acidic. Okay? You add two weak acids together, you get a strong acid. Weak acid with a strong acid, even stronger acid. Any acids together get more acidic. That's the way it works. Okay? So if this goes up, that's automatically going to go down. Can you have a low pH without having high amino acid and having? Yeah. What if you ate lots of oranges? Okay? A lot of this. So the cholecystokinin might not be secreted, but this would be. Makes sense.
So do they need to know that comes from eating meat?
Well, I want you to think through the process, yeah. Because you know amino acids make up proteins. And you know proteins are in meat, right? It's a thought process of like just logically thinking through it, all right? So cholecystokinin, what does it target? Gallbladder. And it causes it to move. Kinin means to move. So when the gallbladder moves, what's coming from it? Bile. All right, so it's going to target the gallbladder. And the gallbladder is going to contract. All right, it's going to contract / secrete bile. Could you say that the gallbladder produces and secretes bile? No, because it doesn't produce anything. Just like your urinary bladder doesn't produce urine, it just holds it. All right, but when it contracts, it flows out. All right? So, it's going to target the pancreas. What is it going to cause the pancreas to secrete? Nope. Look at it. It's going to cause all the other secretions. See, it's being secreted because of the content of what you've eaten. And you need that digested, right? Where secretin is more about the pH. So it's going to cause bicarbonate ions to be secreted because it reverses that pH. But this is more about the content of what you've eaten, right? So this is going to increase everything. Nucleases, lipases, trypsin, and chymotrypsin, and probably amylase as well, just because it's probably all part of that big soup going on. Okay? Lipases. That's it.
Wait, really?
Wait, really? Yeah, really. That's it.
Wait, have we ever reviewed urinary? We did that like all this week, but we don't. Urinary.